So I'm gonna stop all the services locally. We don't need them anymore. Let's delete those terminals. And in the root directory of our project, I'm gonna create .gitlab ci.yaml file. So we're gonna have one pipeline configuration for all the services in this application. In order to keep things simple and to focus on the parts that are specific for microservices and monorepo configuration, we're gonna simplify our pipeline. So we're gonna directly build the image. So we're gonna skip the test phase because we already know how to do that. So we're gonna build the Docker image and deploy to the development environment. So we're gonna have these two jobs in our pipeline. When we have that and we have learned all the concepts, you can apply the knowledge to build out the pipeline with additional steps if you want to. So this way we can avoid too much clutter and noise in our pipeline and focus on the main concepts. So first let's define our stages. And we're gonna have two stages, build and deploy. And for build stage, we're gonna create a job that will build and push Docker image of a microservice in one job, in one step basically. So we're not gonna have a separate build and push jobs, we're gonna have it in one. But we're building 3 different services, which means we need to have 3 different build jobs for each service. So let's go ahead and do that. So we're gonna have build front end, and this is gonna be in the build stage. Let's define the tags over GitLab runner, EC2, remote, and shell. Then we have some before script logic. The very first thing we want to build the image is to enter the front-end directory, because everything for building the image, or basically the Docker file, is inside that folder. So we're gonna go into front-end. We're also gonna export the variables that we need. We have the image name and the predefined variable from GitLab CI/CD, which is CI registry image, which will reference the container registry of this project. And because we're gonna build multiple service images and they're gonna be all stored in the same container registry, we need multiple image repositories. So we're gonna create them using this path definition like we saw previously. But here in monorepo, we actually need this because each service will have its own image repository to differentiate between them, right? So microservice and the name of the service, frontend. Let's also export the image tag. And let's say the frontend microservice is at version 1.3. And then we have the script. And this is where we do Docker login, Docker build, and Docker push. And I'm actually going to copy this logic from the previous pipeline because it's the same. So this is our Node app project. So Docker login command will be the same. We're using the predefined variables from GitLab CI/CD. Then we're going to build the image using image name and image tag. And now that we are in the frontend directory, this is going to be the location of Docker file, which is right here in the frontend folder. And finally, we're going to push that image that we built to the Docker registry. And again, image tag instead of the version. Cool. So that's going to be build job for the frontend service. And the same way we need to create build jobs for other 2 services. So let's go ahead and do that. I'm actually going to copy this whole thing and we're going to just substitute whatever is specific for the other services. So build products with the same stage, same tags. Here we're going to change the name of the microservice to products. And let's say this is at version 1.8. As I mentioned, the microservices are built and deployed separately so they can have completely separate and independent versions, right? And here as well, we need to change into products directory, and all these will stay the same because it's all parameterized. And finally, build shopping cart. Build stage. This is going to be shopping cart directory. The image name, and let's say this is at version 2.1. So we have 3 jobs for our services. However, with this configuration, every time any one of those services changes, we make code changes in front end, products, whatever, all 3 jobs will run in parallel, which is not what we want. Instead, we only want to build the service that has changed. So if the code changes were made in the front-end folder of the project, only the build front-end job should be executed. So these 2 should be skipped actually. So how do we configure that? It's actually pretty easy. What we do is we basically just add a condition to the job that says when to run it. So right here, in build frontend's job, we're going to add a condition using keyword only. And we learned this keyword already when we limit it to run our job only on master, branch changes, etc. So that's the same condition keyword, which basically limits when the job should be run. And inside that, we can say only when changes happen in the frontend folder in any directory, any file inside the frontend folder, only then execute this job. So if something changes in the shopping cart folder, this will be skipped and ignored because this condition will not be met. And the same way, we can limit the other 2 jobs. So right here, we're going to do a condition where we only want to run this build when something in the products folder changes. And let's copy that. And this is going to be shopping cart. Pretty easy. So with this condition, we have a very flexible way of saying when should each job be executed. And in our case, we want to run them when the respective service has code changes. So with this, we actually have our build configuration ready. We can also add a standard workflow rules at the beginning, which says that we only want to build this when a main branch has the changes or on merge request. So with this, we can actually already test our pipeline and validate that our services are building separately whenever something changes in that respective service. So let's open the terminal and I'm gonna push these changes to the repository. Let's add release, pipeline, and git push. And here we have our pipeline configuration we just added. And if we go to CI/CD and pipelines, we should see that no pipeline was triggered, even though GitLab detected the gitlab.ci.yaml file, because we haven't made any changes in any of those folders, so all the jobs were skipped. Now let's actually test that. So let's go to frontend, and in the service.js, I'm gonna make some change, doesn't matter. We can even edit a comment. So test, and let's commit, go to the pipeline, and we have one pending pipeline, and let's wait for the result. So our pipeline has passed. Let's look at the jobs that were executed, and we see that only build frontend job was actually executed. And this should have built and pushed a Docker image in the container registry of the project. So let's go ahead and check that one out. The container registry, we have microservice, frontend, an image with the tag 1.3. And the same way, if we change something in product service, and again, let's add some comment here. This will trigger a pipeline with build products job, which will build and push the product service Docker image. And let's check that one as well, container registry, and we have our product service. with version 1.8. Cool, so we have our build job configured. Now let's go back to our pipeline code. And you probably already noticed that we're repeating a lot of code and configuration in our 3 build jobs. And imagine if we had 10 microservices or 20, we would have this whole code and this whole configuration 20 times in this pipeline. So there will be a lot of repetition. So let's go ahead and optimize and actually reuse that logic using the feature that we already learned called extends. So let's create a generic hidden job, and we're going to call it build. That will contain the common configuration logic. And then each specific service job will extend from it. So I'm going to take the whole configuration and put it here. So first let's paste the whole configuration in our base build job. And then let's see what parts we have to customize or what parts we have to extract out again to the specific job. So first of all, we have the stage, which all the jobs can reuse. We can also say we want all the jobs to be run on the same runner because we just have one runner, right? So these 2 configuration attributes can stay, obviously. Then we have before script where we use explicitly the microservice name and the version of that microservice that we're building. So these obviously have to be parameterized and customized. And we've learned that we can pass parameters to a base job that we're extending from using variables. So let's go ahead and do that right away. We're going to define variables, and this is going to be the microservice name. So we can call it microservice. And in the default job, we're going to leave it empty. And we're going to have the service version, so to say. So with these 2 variables, we can make this generic, and each job will basically pass their own values here. So before script is also configured. In the script, we already have everything parameterized, so we don't have to change anything here. It is already generic, it can be reused. And finally, we have this expression to only execute the job when changes in the microservice folder happen. Now, it would be great if we were able to use that microservice variable in here as well as a substitute for whatever service folder that is. However, in GitLab, it's unfortunately not possible. So the variables do not get expanded in certain places, and one of them is this only changes attribute. So we cannot use an environment variable here. It's not going to work, which means we're going to grab that and put it back to the specific job that will extend the base build job. However, all this configuration is now generic and we don't have to repeat this code. So let's go ahead and extend from it in our build frontend job using the extends keyword and pass those 2 variables to customize the job specifically for frontend. So we're going to do frontend as a microservice and the version 1.3 inside the string, because otherwise it gets interpreted as a number value. So, and this way you see the specific job implementation is just a couple of lines. We can do the same for the other 2 services. I'm actually just going to copy this whole thing. Products, we have image tag 1.8. So let's change that, 1.8. Service name is products. And same here. Shopping cart and version 2.1. Awesome. So we have reduced our pipeline code by reusing the common configuration, which is pretty large. So if we had 5 more microservices, we would actually be saving a lot of repetitive code. So now let's actually commit those changes and make sure that our pipeline still works as before and it still builds and pushes the images correctly. So get the terminal. Let's do git add. And commit message reuse build job for services. And let's pull the changes we made in the front end and product service. And now we can push our own changes. And of course, the pipeline will not get triggered because we changed the pipeline configuration, which is in the root. So all these jobs get skipped. So now let's go and change something in the front end again. Let's actually remove this test that we added here. And this should trigger a pipeline with build front end job. So let's wait for this one, make sure it's green. Cool, so everything still works fine. Let's also check the repository. The front end published 2 minutes ago. Cool, so now that we have created and also optimized the build job for our services, let's go to the next stage and create deploy jobs. And we're gonna use Docker Compose to deploy each service. So we're gonna create that Docker Compose file. But each service will be deployed with its own Docker Compose file because they need to be deployable separately. Plus, when we do Docker Compose down in order to stop the previous version of the image and start a new one, we don't want to stop any other services, just the one that we wanna update. However, we also don't want to duplicate code and have 3 Docker Compose files. So what we're going to do is we're going to create a generic Docker Compose file in the root of the directory that all services can reuse, and we're going to make it customizable for each service. So let's go ahead and do that first. dockercompose.yaml. And this is going to be a very simple Docker Compose with one service, and we're going to make it generic. So we're going to call it app. And the image will be customizable. So that's going to be an environment variable, and let's call it image name, just like in our previous demo. And then we're going to have the image tag that can be set separately. We also want to customize the ports because each service has its own port. And we can have separate ports for the host and container. In our case, let's just go with one. So whatever the container port is, we're going to use the same for the host. So let's call it Docker Compose app port. And same for the host and container. And that's it. So with this, we're going to be able to use this Docker Compose for each service to deploy them without affecting the containers of other services when deploying the service with this Docker Compose. So let's go to the pipeline configuration and create deploy jobs for all 3 services. We're going to start with the base deploy job. Let's set the stage on deploy. Then we have the tags. I'm actually going to copy that. And then we have before script and the main script. In the before script, we have 3 things we want to do. First, we want to limit the permission on the SSH private key of the deployment server. And we will actually have to create this variable in our project's global variable section. So we're going to do that later. But when we have our SSH private key in our project's variables configuration, and we're going to create it later to make it available for the pipeline, we're going to limit the permission to 400. Otherwise, AWS will not allow accessing or SSHing into the server. Then we want to set the 2 environment variables. One is image name. And actually, I'm going to copy the code from above. Also want to set the image tag. And this is going to be also the service version. So that's the before script, and inside the script, we're going to connect to the deployment server, the EC2 instance that we created. We can actually call this deploy micro services. So we're going to connect to the server using the SSH private key, and copy the Docker Compose file. And as a next step, again, connect to the server and execute Docker Compose. This is actually the same deploy logic that we used for our Node.js application in the previous demo. So we can actually copy it from there. So this is the part that copies the Docker Compose to the server. And this is the part that does Docker login and then starts the containers in Docker Compose file. But I'm going to write this step by step so we can refresh our knowledge. So we are doing secure copy we're disabling the strict host key checking, so it doesn't ask for it. We are also passing the private key file, and we're copying docker compose.yaml, this one here, to the remote server using Ubuntu user. And we're going to save the public IP address of the remote server in a variable, which we're going to call deploy server or deployment server host or IP, whatever you want to call it. And inside that, we're going to choose a directory where the Docker Compose file will be copied to. So in the Ubuntu user's home directory, we're going to have Docker Compose file. And once we have that, we're going to SSH into the server, again using the same private key, using Ubuntu user and the public IP address. And we're going to execute following commands. First, we're going to do Docker login. And I'm actually going to copy that. So Docker login, this is the same Docker login we used here. This is absolutely parameterized with the predefined variables that GitLab gives us. Do not forget the end signs at the end so that we can execute more commands. Then we have Docker Compose up command, which will take this Docker Compose that we just copied, and using that file, it will start all the services that are defined here. In this case, we just have one service, so it will start it. But if we already have running containers, we have to stop them first, right? So we're gonna do Docker Compose down before to remove or to stop any old containers of that service before we start the new one. And we also parameterized our Docker Compose. So obviously we need to set all these environment variables before we start the Docker Compose, right? So Docker image name, which will be whatever we put together here. Then we have image tag, which we also have here. And we have the app port, which we don't have here, so we need to basically pass as a variable. And we're going to call that app port. So we're setting all three environment variable values on the deployment server before we execute Docker Compose up command so that it can substitute those placeholder environment variable values with the actual values. So everything is parameterized here, which means we have to actually pass those parameters from outside to the deploy job when we extend from it. So we're gonna specify variables here, and we have actually three variables that we're gonna set. So microservice, that's the one, the service version, that's another one. The SSH private key comes from the global variables that we're going to create in our variable settings. So it's directly accessible. We don't have to pass that. All these are predefined variables, again, directly set. The app port needs to be passed as well, because this is going to be different for each service. And we also have deployment server host. So this is the public IP address of the server, of the deployment server. And this is going to be the same for all the services. So we can actually specify them, or we can set them as a shared variable at the beginning. And the value will be the public IP address of the deployment server. And let's put it into quotes. So now we're making all the variables configurable. And there is one final thing that we would need to do in our deployment logic, and that is setting another variable which is specific for Docker Compose that we already learned actually, which is compose project name. And this is going to be set to the microservice value. So we already learned about this environment variable. So basically what it does is it overrides the prefix that the container name gets when we start it from the Docker Compose file. By default, when we start the container inside the Docker Compose, the Docker Compose will put together a container name using the folder where the Docker Compose is located. That will be Ubuntu users home directory, Ubuntu, underscore the service name that we have here, and then suffix with an index. So that's going to be the container name. And if we leave that as the default, what will happen is that all our three services, front-end products and shopping cart, will have the same container name. And we don't want that because we're only going to be able to start one container. Instead, we want them to have different names. So what we're going to do is we're going to overwrite the prefix and we're going to make it the microservice name. So the front-end container will have this name, the products container will have this name, and so on. And in order to do that, to overwrite the prefix, so instead of being the folder name of Docker Compose file, we're going to set it to the microservice name. And that's what the Compose project name environment variable is used for. And let's put this quote on the same line to fix the issue. And this actually configures our base deploy job. Let's also add an environment. So we can see a direct link to the URL. In this case, it's optional because we just have one environment, but we can still add it. And let's make the URL also configurable. And let's do application endpoint. And this will also be a global variable. And this could be the same as the public IP address in this case, or it could be a DNS name, which is different from the server endpoint. So in our case, these are exactly the same. You can use any for both values, but we're just going to leave it at that. So we have the base image. Let's now create the specific images for each service. Let's do deploy frontend first, which will extend from the deploy. And we'll set those variables. So the microservice is frontend, service version is 1.3, and the application port is 3000. And don't forget that we also only want to run deploy frontend job if something in the frontend service changes. So we're going to add this same condition, only changes in frontend directory in the deploy jobs. So now with this logic, if something in the frontend changes, the build frontend and deploy frontend jobs will be executed. All other jobs will be skipped. So that's our deploy frontend configuration. I'm going to copy that and let's create the other two jobs as well. Deploy products. The version we set to 1.8. The app port is 3001. And only changes in products. And shopping cart. Version 2.1. It runs on port 3002. And there you go. And I actually forgot to set these ampersand signs at the end of every command because we're executing them as a chain of commands. So let's make sure to add them after each command. Now there's one more thing we need to do in our Docker Compose configuration, And that is specifically because we're deploying our services with separate Docker Compose files, so to say. So in Docker Compose, by default, what happens is when we start the services inside the Docker Compose with Docker Compose up command, Compose will create a Docker network, and all the services that are listed in the Docker Compose file will be started in that network. So if you do docker network ls on your terminal, you will see a list of networks that has been created on your machine, right? And each network, you can think of it as an isolated virtual network that has a possibility to run containers inside. And with Docker Compose, whenever we start services in Docker Compose will create a new Docker network, and all the services will run inside that network. And the name of that network by default will be the folder name, wherever the Docker Compose file is, _ default. So for example, if I'm in a source or src folder and I have Docker Compose file inside, when I execute Docker Compose up command, it will create a network called src _ default. So that's the default name. In our case, it's going to be different because we have set this environment variable for Docker Compose, which sets the name of the project or Docker Compose project to microservice name. So this is going to be front end or products or shopping cart. And this actually overrides not only the container name inside the Docker Compose or the prefix here, but also the name of or prefix of the network. So this value will be used instead of the folder or folder name when creating network as well. So we're going to get a network which is frontend _ default like this, and our frontend _ app _1 container will run inside that network. And the same will be true for products and shopping cart services. However, there's a problem with that because when you have containers in different Docker networks, they cannot communicate with each other. So they can't talk to each other from different networks. Of course, there are different tools to configure that they can start communicating, but by default, without any configuration, they can't talk to each other. So we want all three containers, when they start, to actually be in the same network. And when they are in the same network, the containers can talk to each other using the container names. So that's what we want. So we don't want Docker Compose to create own network whenever it starts the front-end application, the products application, and shopping cart application. We want it to create one network and start all three applications inside. So instead of products _ default or frontend _ default, we want some one consistent name. So how can we overwrite the name of the network that Docker Compose creates? Well, we can do that inside the Docker Compose configuration. So first we have to define the network that we want to create. So networks attribute will allow us to create any number of networks, and then we can reference them inside our services. So first we're going to specify the network name that we want to assign it, and let's call it microservice. That's going to be the name of our network. And there is one required attribute for any network, and that is a driver. We have different values like host, driver, or bridge, or it can have a custom driver. We're going to go with the bridge driver. That's what we want. That's basically what the Docker Compose will use by default. So we're going to specify that. We're not changing the default behavior here. However, we still have to do one thing here, because setting the name of network here, so this microservice, this will actually only replace that part of the network name. So it will not substitute the whole name, it will only substitute the second part. So this default part basically. So it will still get assigned the prefix, which will be either the enclosing folder or, in our case, the value of Compose project name. And we don't want that because that's going to be different for every service, and we want as the same consistent network name. So how can we overwrite this part as well? Well, we're going to say, you know what? Docker Compose, do not do what you do by default. Take this instead as a network name. So with this, we're replacing the default naming convention of Docker Compose using our custom name. So the network that Docker Compose will create with this file will always be microservice, regardless of what the value of this environment variable is. So that will solve the issue of the network name. Now we have to also reference that network in our services. Otherwise, Docker Compose will use the default network for the service. So here in the configuration, we're going to do networks. Again, you can start your service in multiple networks. And in our case, we want it to start in microservice network. And that's it. So now the very first time when our Docker Compose starts, the microservice network will be created, and each service container will be then created in that network. So our containers will be running in the same network, which means they can talk to each other using the container name. In our case, the front end is talking to the other two backend services. So if I go to the Docker file of my front end, you see that we have this product service and shopping cart service, which are essentially the endpoints we have configured here. So products endpoint, shopping cart endpoint, and that's the endpoint where we talk to the other services. And we're setting those values here. And when we start them using this Docker Compose and they are in the same network, frontend can access the other containers using this name. And when we deploy those services, we're actually going to see the names. So that's the service name that we have here. That's the microservice name that we are setting here. And that's the index. So with this configuration, frontend should be able to talk to the products and shopping cart services. So this will allow Docker Compose to create its own network, but alternatively, we can actually use an external network inside Docker Compose. So we can tell Docker Compose, do not worry about network, we already have one that we created, and please use that to start the services defined here inside that external network. So instead, we're going to use an external network, and the way to do that is basically inside the network name. So this is the reference here. And inside that, we're going to say this is going to be an external network. And the name of that external network is also a microservice. So we're going to remove the driver because we're not creating, or we're not allowing Docker Compose to create its own network. We're saying to Docker Compose, please do not create a network. Use an existing one that we already have created. So it already has its driver. So no configuration needed for that. Just find a network on the machine that is called microservice. So that's going to be the Docker network name. And then we're going to reference that external network inside the Docker Compose also as microservice, and tell Docker Compose to run all the service containers inside that external network. And we're going to take care of creating that network ourselves using simple docker create network microservice command. So right here, before we run the Docker Compose down and then up command, we're gonna create that network using docker network create and the name of the network, and that's it. And let's not forget the ampersand at the end. So this will basically let us create our own network and then tell the Docker Compose to run any service inside in our managed network. So this will basically fix that issue that we're having. So obviously there are a couple of options here that you can choose from, and you can get creative with these solutions, but that's the one we're going to use here. So this will create the network called microservice, which we are going to then use inside Docker Compose, telling Docker Compose to start any services inside that network. And this will succeed the first time. The second time, however, if the network already exists, then Docker will complain and fail this command. So this is going to fail the second time. So we're going to have to add some configuration here that says if the network with the name microservice already exists, then just return the result and continue with the next line. And the quickest way to fix that is to say either this, so if this doesn't work, basically just return true. So that's kind of quick fix of the issue. So if this errors, so to say, or if this fails, just return true and then continue with the next command, ignoring that issue. So this is our pipeline configuration. Now let's not forget to create this SSH private key variable before we commit this, because we are referencing it in the pipeline. So let's copy that, go to our variables in our project, and we're going to create a protected variable of type file, and microservices, and we're simply gonna print this out, copy this whole thing before, so not including the percentage sign, copy that and paste it in here. And that's it. Add variable, and now this should be accessible for our pipeline. Let's commit those changes. Add deploy jobs and Docker compose. Let's pull any changes and git push. Now again, pipeline will not be triggered because we haven't changed anything in the services, but we do want to deploy all the services so that we can see them in the UI. So let's actually deploy them one by one. Let's go to the front end first. And let's do deploy test. Commit, and this should trigger the pipeline. So now we should have two jobs, build frontend and deploy frontend. All the other jobs get ignored. And this should deploy the front-end service on our deployment server. And I'm going to close all the tabs that we don't need anymore. And let's wait for this pipeline to complete. Cool, our pipeline has passed. We have deployed successfully, which means we should be able to access our application on the public DNS or public IP address of the server at port 3000. However, we need to open the port 3000 in our firewall configuration. So let's go ahead and do that first. So we have security groups, view inbound rules, only 22 is enabled. So go to inbound rules and we're gonna add a rule for port 3000. Save rules. Let's go back to our instance, copy either the public IP or public DNS. Both will work, and access the application on port 3000. And there you go. This is our front end. Now, products and shopping cart are not deployed yet. So let's go and deploy them. And we're just going to simulate a change in each one. Here, let's just remove the test that we added, commit. A new pipeline is in progress with build products and deploy products jobs. So product service has been deployed, and we can see that both containers are running on the server. If we do docker ps, so we have the frontend app1, that's our frontend container running on port 3000, and this is our products container running on port 3001. And we can also check the network that we created using docker network create command. We have this microservice network here, and both of these containers are running inside. We could check that using docker inspect command like this, and we can grep network, and there you go. So we have this network mode here, which is microservice. And if we check that for the other container as well, there you go. So they're both in the same network, which means the front end can talk to a product service using its container name products_ip_1, which is what we have set as an endpoint in the front end application's Docker file, right? So that's the product's endpoint. So now the moment of truth, I'm going to refresh the front end real quick. And if I click on view, I should see the result of products application. And finally, let's do the same for the shopping cart. Let's change something here. I don't know, just remove the line, whatever. And the pipeline should now trigger that will deploy the shopping cart application as well with build shopping cart and deploy shopping cart jobs. So again, we know what the build command does. In deploy, we're doing Docker login. All these environment variables will be created. The Docker network microservice already exists, so this will be ignored and it would just return true. There is no previous container to remove, so this will also be ignored. And then Docker Compose up will start the shopping cart container in the microservice network, so frontend will be able to talk to it. So let's wait for that pipeline to complete and deploy the shopping cart service. And once that step is completed, go back to the application. We actually don't have to refresh this. We can just click on view and there you go. We have a response from the shopping cart. So our application is working. So all three of our services have been successfully deployed using our pipelines. And from now on, we can individually update, build, and release each service without affecting the others. And that's how CI/CD pipeline configuration for monorepo microservices application works. Cool, we saw how to create a release pipeline for microservices application in a monorepo. Now let's see how a release process looks like for a polyrepo equivalent of the same project. So first, let's create the polyrepo or multiple repositories for our microservices. So instead of the project, we're going to create a group, and then inside that group, we're going to have individual projects for all three microservices. So I'm going to go to the groups and create a new one. And let's actually call these the same as our microservices project was called. So in this case, this would be the group name. In a real life scenario, this will be the name of the application, like my online shop or whatever application you have. Obviously, I'm very bad with the names of the projects and groups, so you can call it whatever. I'm going to make this public so that you have access to it. And that's it. I'm going to create the group. And now we have an empty group, which can host multiple projects inside. And we have this new project button, which allows us to create multiple projects or even subgroups inside. In our case, we're not going to have any subgroups. We're going to create 3 projects, one for each service. So let's go ahead and do that. First, I'm going to create a project for frontend. So let's call this frontend, and you see the project URL is gitlab.com, the name of the group / the project name. If I'm creating a project in my GitLab account without or outside a group, then instead of the group name here, I will have the username of my GitLab user. I'm also going to make this public, and let's initialize this with readme and create the project. So that's the frontend project inside this group, and we have this listed here. Let's create another one for the products service, again public and with its own readme, and the third project for the shopping cart service. And there you go. So we have 3 empty projects inside our microservice CI/CD group. And now what we need to do is basically take all the code for frontend service and put it in this frontend repository and do the same for all other projects. You can clone it locally and basically copy and paste from the folder, or you can do it in the web UI. It doesn't really matter as long as we end up having the same exact files in our individual service projects. So what I'm going to do is I'm going to switch to the web IDE for the front end, and I'm going to create all these files here. So I'm going to create the Docker file. Let's create the package.json, the index.html, and server.js. Not the most efficient way of doing it, but it doesn't matter. You can do it any way you want. So I'm just gonna take those contents and paste it in. Then I'm gonna grab the index.html and paste it in here. Let's grab the package.json and finally the server.js. Cool, so we have all the files that we need in our front end, and we can commit those. You can choose commit directly to the main branch. We're not going to create a separate branch for it, and front end project has all the files of the front end service. So let's go back to the group and do the same for the products. And I'm going to skip the video here and basically fast forward to the final result, but you should go ahead and do the same for other services. So basically just copy all these files. You don't need the package log.json because this will be automatically created. So copy the Docker file, package.json and server.js to the products and shopping cart services. And I have copied all the code in the respective service projects. So we have our front end with its code, products with its Docker file, package.json and server.js, and the shopping cart service. So we have our polyrepo microservices project. And now let's go ahead and build a CI/CD pipelines for our microservices. And same as for our monorepo project, let's actually go ahead and prepare a couple of things before we create the pipelines. First of all, we need to configure GitLab runners for our projects. If you go in one of those projects, you have exactly the same view as for any other project that is existing outside the group. So this is exactly the same configuration. We have the same CI/CD views here with pipelines, editor, etc. and the CI/CD settings where you can configure variables, runners, and so on. And right now we don't have any actively configured runners here. But as I told you, in a group we have an advantage that we don't have to configure these things individually for each project. Instead, we can actually share some of the configuration. So on the group level, you can also see that we have some of the common configurations. For example, we have the container registry, which is for the whole group. We also have the CI/CD runners, which can be reused by the whole group. So we can have group runners. And the same way we have the settings for the whole group that all the projects inside can use. So we can define shared variables, shared runners, etc. So as a first step, let's create a group runner that all the projects inside that project can use. And this time we will create a new runner on our remote runner machine and register it with our group. You can go ahead and register a local runner if you want as well. It doesn't matter as long as you have Docker up and running on it. And we already learned how to configure a local runner, so it will be a refresher. So as you remember, for registering a runner, we need the token. And instead of a project token, in this case, we're going to need a group token. So if I expand the runners, they actually changed the UI configuration a little bit. So it has a button that takes you actually directly to this runners section here. And they made the overview a little bit better. So you have a list of all the runners, the group runners and project runners, because again, you can have runners that are only specific for one of the projects inside the group, or you can have shared group runners. Right now we don't have any. And if I click on this register a group runner button, you have this button here that doesn't actually look like a button, but if I click on this, it gives you like a cheat sheet command list for installing the runner on a fresh new environment and then registering a runner for each environment, each supported environment. So this is for Linux, Mac OS, Windows, Docker, and so on. So this can be very helpful if you're creating a completely new instance and registering a runner. So you can basically just grab your commands from here. So that's the token of the group for authenticating and registering the runner. So what we're going to do is we're going to SSH into our GitLab runner server and register our group runner using this command. So let's go ahead and do that. Back to my terminal, I'm going to do SSH command, and this is my GitLab runner key and the GitLab runner public IP address. And here I'm going to basically paste in this command. So copy, and let's make this a little bigger. So I'm going to copy this command, paste it in here, and execute. So this is the instance. This is the token already filled out, so we can just enter the description. Let's call this remote group runner, and let's call it remote group and shell, because we're gonna register a shell executable. Let's leave this empty and choose shell executor. Cool, so GitLab runner is registered. We can also check the status. GitLab runner status. Looks like it's running, and we should be able to see the runner already registered with our group. So if I refresh, there you go. We have a runner that needs to come online. So we're gonna wait for that to become active. And these are the tags that we assigned. And since we're going to be building Docker images and deploying using Docker Compose, obviously we need a runner for our project inside the group, for a microservices project that has Docker and Docker Compose both installed on them. So if you're creating a runner on a different instance or locally, make sure you have Docker and Docker Compose available. Let's refresh again. And this may take some time, but let's wait for the status of the runner to get online, and then we'll be ready to move on. And our group runner is online, which means it is ready and available to run our jobs. Cool, so that part is configured and done. Now as a second step, let's prepare our deployment environment. And we're gonna reuse the same server that we used for the monorepo project. But in order to be able to reuse that, we need to stop all the Docker containers currently running on them, remove the containers, remove the images, so we are starting from the fresh state. So I'm gonna SSH into the server. So make sure this is the right one. We are in the deployment server where we have our Docker containers running. And as a first step, I'm just gonna stop all of them using the container IDs. And I forgot Docker stop. There you go. Now we can remove all the containers using docker rm command. Great. Let's check the images and remove them as well. Docker rmi for image. Shopping cart 2.1. Then we have products 1.8 and frontend 1.3. And it seems like we still have some containers. Let's get rid of them as well. And now if I do docker images, there you go. Everything is empty. One more thing, we have the network microservice that we created. So let's get rid of that one as well. Network RM and microservice. So these three are the default networks that are there by default. And we're gonna delete our own microservice network. So now we have a fresh state for completely new deployment. And as a final step for pipeline preparation, we're going to create the SSH private key variable for the deployment server so that GitLab can connect to that and deploy the services. And as I mentioned, in a group, we can create shared variables that all the projects can reuse instead of having to create the same variable 3 times for all 3 projects. So in the settings, CI/CD of the group, we're going to create this variable and call it SSH private key. And this is going to be a file. And just like before, let's actually exit here. So the deployment server key is the one we need. So I'm simply gonna cat this and let's copy the whole contents till the %sign and paste it in here as a value. So I'm gonna add the variable and that's it. We have prepared everything that we need for creating the pipelines for our 3 projects. So now let's go ahead and create the GitLab CI.yaml file for each of our microservices. Going back to the group view, front end, and I'm going to switch back to the web IDE. And again, you can do this locally if you want in your local code editor. It doesn't matter. I'm just doing it here so that we can save some back and forth switching and so on. Cool. So let's create the same pipeline as for our monorepo that will build and push a Docker image to the registry and deploy that image. And for deployment, we're going to use the same Docker Compose file that we used here. So what I'm going to do is first I'm going to create the Docker Compose file and I'm going to copy that actually from here. So it's going to be exactly the same configuration. And this time we're going to have to create this Docker Compose file in each project because we don't have a shared repository, right? So in the front-end project, I'm going to create a docker compose.yaml and copy the contents here. We could make this more specific because again, this is in the front-end project, so it's obvious that it belongs to the front-end. So we can call this front-end instead of app and hardcode the ports, for example. However, we're still going to keep it generic and customizable because we want to keep the pipeline code generic. And we're going to see that when we create the pipeline. So let's go ahead and create our GitLab CI.yaml file. I can actually just click on this one. And what I'm going to do is I'm going to just basically copy and paste in the pipeline code directly because we have written this same logic a couple of times. And let's go through and explain what's inside. Let's fix this tab characters here like this. So let's go through the configuration. We have written this configuration multiple times already, but let's see exactly what we're doing. So first of all, we have the variables, server, host, and endpoint, which are of our deployment server. Let's make sure we have the right public IP. That seems right. And then we have 2 stages, build and deploy. And we have specific jobs, build front end and deploy front end. We're building and pushing the front end image to the repository, and we're running them on our GitLab runner. Let's actually check that our tags are correct. Runners, so we have remote group shell. Remote group shell. We already know this configuration. Deploy frontend is also running on the same runner. Again, using the private key, setting the image tag. And this is actually exactly the same code as we had right here. So it's the same pipeline configuration that we used for our monorepo. So this part is where we set the compose project name, the app port, and create a Docker network, compose down, compose up. Same thing. The difference here is that we have specific jobs and hard-coded values. So let's actually parameterize them and make them into variables so that all specific values are set as variables. So we have a better overview of what values are different. And also we will be able to copy and paste the same pipeline configuration for other services where we would just have to change the variables. So all these values here, we're going to extract them into variables. So let's set them. First we have the microservice, which is front end. Then we have the service version, which is 1.3. We also have the service port, which is port 3000. And now let's substitute those values everywhere. Service version, same here. And frontend runs on port 3000 actually. Let's copy that. And there you go. So all of this is now exactly the same as we had here in the base job. So all parameterized, and we're setting the specific values in variables. Even though this is a front-end project and we know that we're building only front-end with this pipeline, but this is going to make it easier for us to, as I said, copy and paste the same pipeline for other services, and later we're going to see how to reuse the same functionality in the pipeline. Cool, so with this configuration and Docker Compose ready, we can actually commit those changes or those two files, which will immediately trigger the pipeline and deploy the front-end service to the deployment server. So let's do that. Commit to main branch, and let's wait for the pipeline to run. And if I click on the front-end project name here, we will go to the default view, and in the CI/CD pipelines, we should see our pipeline, which is in progress. Frontend has been deployed, which means we can now access our application or the front-end part of it on the public DNS. So let's check that real quick. There you go. So we have front-end up and running. Let's go ahead and configure pipelines for products and shopping cart services as well. And this will be basically the same exact configuration. So I'm going to open the products repository. Let's go to web ID because we have to create two files, and I'm going to copy them from here. So the Docker Compose file, because we made it so generic, it's going to be exactly the same. We don't need to do any adjustment. And let's paste it in there. There you go. And second will be the GitLab CI.yaml. And this one as well is pretty generic. The only custom or specific values are in the variable section. So we can easily copy and paste that one as well. So all of this stays unchanged. We're just gonna change the values in the variables. So the dev server is the same, endpoint is the same. It's the product service version 1.8 and port 3001. Let's trigger that pipeline as well for the product service and wait for that one to complete as well. Product service is also deployed, which means if I go to the front end and click on view products, I should get the response. And finally, let's also deploy or create a pipeline for the shopping carts service. So going to the shopping cart, web ID, let's create GitLab CI file. I'm just going to copy the pipeline configuration here, change the values. Shopping cart, I think we set the version at 2.1 previously, 3002. And we also need the Docker Compose. Let's grab that one as well. Commit those two, and there you go. So this should trigger a pipeline that deploys our shopping cart service. So let's wait for that one as well. And finally, the shopping cart service is also deployed. Going back to the UI, if I click on view, there you go. Shopping cart is returning a response. So we have successfully created a poly repo for our microservices application and configured release pipeline for each of the services inside that poly repo.